All right, so we just finished doing radicals, so now we're going to move on to the theorem of Pythagoras. Pretty sure you remember that from middle school. So we're going to change it up a little bit now that you're in high school. So let's just get right to it. So parts of a right triangle we need to know. The main one being the hypotenuse. We got to be able to identify the hypotenuse. So this is always going to be your longest side. Okay, it's going to be your longest side, which is also across from your 90-degree angle. Okay, so your hypotenuse is going to be this side right here. And then the other two sides we call the legs. Okay, and so this will just say the sides adjacent to the 90-degree angle. Okay, so we have a leg right here and a leg right here. All right, so those are the legs and that's the hypotenuse. So something that we want to show you different in high school is why the Pythagorean theorem was, or how I should say, the Pythagorean theorem was derived. And so usually we'll let you investigate this and dissect this using your construction tools, but you're just going to go ahead and kind of follow my lead, and we're going to divide, which let me explain where this comes from right here. So this right here is the blue right triangle. Okay, so this is a right triangle. So this is a leg, which we'll call A, and this is a leg, which we'll call B, and this is the hypotenuse, which we'll call C. And so you guys know from middle school that A squared plus B squared equals C squared, but let me show you how Pythagoras derived that. And so what he did was he wanted to see how, the area of this space right here, which comes from B, and B is also the side length over here because this is a perfect square. Okay, same thing goes over here. This is a perfect square, which all of the sides are going to be A, and then this square over here is C. And so he was trying to figure out how this space and this space could be related to this space down here. Okay, and so this is what eventually he figured out. And so I'm just gonna, you can follow along with me, and I'm going to show you how this entire space and this piece up here is going to end up being the same as this space down here. So I'm going to turn these into little puzzle pieces so we can investigate it that way. And you're going to see how they fit perfectly into the square down at the bottom. And you can use your colors or highlighters to work with this as well. So color this 3 different colors. Okay, and actually I need a 4th color, so we'll color this one orange. Because remember, A squared plus the B squared has to be able to fit into the C squared. Okay, so now that I have all of my puzzle pieces, okay, we're going to see how this fits. This is a perfect right angle right here, so I'm going to fit that one right here. This is a nice right angle here. This one's a nice right angle, and then this one down here. And where do you think that remaining space is for that piece right there? So you can see how the area of B, which is B squared, okay, now let's think about that area. Area of, sorry, the area of this square over here is B times B, length times width. which is equal to b squared. And the area of this little square over here is a times a, which is a squared. And then the area of this big square down here is c squared. And so you can see clearly how I fit the puzzle pieces of a squared and b squared perfectly into c squared, okay? And that's how he derived the formula. So let's write that down just to have in our notes. In a right triangle, the sum of the squares of the lengths of the legs equals the hypotenuse squared. And you could also say it the other way, the way they started off, the square of the hypotenuse, okay? And so our formula is a squared plus b squared equals c squared. Okay, and I know you've used this before in middle school, so should be very familiar. All right, over here, some triples. So what are Pythagorean triples? These are 3 whole numbers that fulfill a squared plus b squared equals c squared, okay? So there are 3 perfect whole numbers that fulfill the equation a squared plus b squared equals c squared. So for instance, 3, 4, and 5, if I were to plug 3, 4, and 5 into the formula, and I'll do that real quick, 3 squared plus 4 squared equals 5 squared, you're going to see, and I'll put a question mark at first, you're going to see how it does work out. So 3 squared is 9 plus 16, and that's 25. 9 plus 16 is 25. So clearly, you see how it satisfies the formula, Pythagorean theorem's formula. So 3, 4, 5, 6, 8, 10, and I wrote these down on your notes too. Okay, I didn't write all of them, so if you want to jot the others too, the other 3 or so down, but I did write down some of these for you on your notes. So these are all triples that fulfill the Pythagorean theorem formula. Okay, so is the converse true? Okay, so we're going to select a triple, and I believe I put on your notes, so let's just do 6, 8, 10. So let's use 6 centimeters, 8 centimeters, and 10 centimeters. And it says, use the compass and the ruler to construct a triangle with those particular measures. Okay, so the first thing that I'm going to do is I'm going to draw a long side right here. Okay, and I'm going to measure out 8 centimeters. Okay, so I'm going to go all the way to 8. I'm going to put my compass on 0, and I'm going to bring that into 8. Okay, so there's 8. I'm going to make an arc right there. Okay, I probably should label that too. So that's 8 centimeters. And then I'm going to use 6 and 10 to make that, to get the other vertex. Okay, so I'm going to come over here to 10. I'm going to place it on one of the endpoints. It doesn't matter which one. And then I'm going to make an arc up there. And then now I need to get the measure of 6. There it is. Let me make sure I have it right. On the 6. That's a bad thing about this because it doesn't go perfectly. And then I'm going to come over here to this other endpoint because I had put the other one over there. And then I'm going to make an arc. So now I'm just going to get my straight edge and I'm going to connect from there to there and from there to there. Okay, and so it clearly does look like it could be a right triangle. Let's double check with our protractor. That is a right angle. So I picked out the 3 numbers, 6, 8, and 10, that do satisfy the Pythagorean theorem. And what did we get? We produced with those exact measures, and I should probably write that down. Remember, this was the 6 centimeter side, and that was the 10 centimeter side. And so we did produce a right triangle, so the converse is true. So if the lengths of the three sides of a triangle satisfy the Pythagorean equation, then the triangle is a right triangle. Okay, so you'll have to know that. So if they satisfy the Pythagorean theorem equation, then it has to be a right triangle. There's no other way around that. Okay, so let's try some examples here. So if I'm going to solve for x, I'm going to use my Pythagorean theorem. I can let that be a and that be b. So it'll be 8 squared plus 12 squared equals x squared or c squared. 8 squared is 64 plus 144 equals x squared. 64 plus 144 is, let me get my calculator because my brain's not too hot right now. 64 plus 144 is 208 equals x squared. Now let me show you what a big difference is that from middle school till now. So you're going to leave this in simplified radical form. So you know your last step is to square root to get rid of the squared. So x equals that. And so when we would put that in our calculator, and sometimes we'll tell you to have the decimal, we get 14.42, okay? But in this case, I want you to leave it in simplified radical form. And so I know 64 goes into 208, I think. Actually, I don't know why I'm saying that. It might. So 208 divided by 64, maybe not. No, that is incorrect. So 64 does not go into that. However, 208, let's try 16. 16 does go into that. So I'm going to do 16 times 13. 16 is a perfect square, so I'm going to circle that and underline that. So the actual length of this is going to be 4 radical 13. So 4 radical 13. Okay, and so you're going to leave it in simplified radical form. Now, if sometimes it says give me the decimal, well, then you would just put 208 and then use your calculator to get the decimal. So that's about 14.42. Okay, but we're going to leave our answers in radical form. So let's do this one again using Pythagorean theorem. If I have to figure out the length of x, okay, or a, let's just change that to an x. So then I'm going to do, well, this is a rectangle because it has 4 right angles, so that's 5 over here. And so I can use this right triangle. Now, so one thing you have to notice is that they gave us the hypotenuse. And so what a lot of students do, they'll quickly just do this. Okay, and that is incorrect because the 11 does not represent a leg. So make sure you realize that. All right, so how do we do this type of problem? We're going to do 5 squared plus x squared equals 11 squared. Okay, I'm going to subtract 5 squared from both sides. And so I get x squared equals 11 squared minus 5 squared. Now, let me make a comment on this too. A lot of students will say that that is 6 squared. That is incorrect. That property does not exist, okay? So when you do the actual work, this is 121 minus 25. Okay, what is 121 minus 25? Not 36, guys, okay? So I want to make that clear that you don't do that property ever, okay? So that's 96, oops. 121 minus 25 is 96, and now I'm going to square root both sides. And so remember we had said I want to leave it in simplified radical form, so I want to do the factor tree to 96. And 96 is divisible by 16, I believe. So let's see, 96 divided by 16. Notice I like to use perfect squares. Yes, 6 times. So 16 times 6 is equal to 96. I know this is a perfect square, and underline that. So x is going to be 4 radical 6. Okay. And that's the length of this side of the rectangle. So we're going to leave it in radicals. And you're going to have to work a lot with square roots and radicals when you go to Algebra 2 next year. All right, let's look at these last page, these last examples. It says determine whether the following sides, the following are sides of a right triangle, meaning would they be a Pythagorean triple? So what you need to do is you need to check it using the Pythagorean equation. But make note of this. I should probably get my highlighter to highlight this. You do always want to check to see if the measures even create a triangle. Remember what it takes to make a triangle. The two smaller sides need to be greater than the third side. So we should probably check that first. So is 14 plus 48 bigger than 58? And the answer is yes. So that one will make a triangle. What about this one? Yes, that's clearly way bigger than 85. What about this one? 15, 16. So this right here, these are our two smallest sides. That adds up to 75. Is 75 bigger than 80? So instead of wasting time and using the Pythagorean theorem, we're just going to go ahead and write that this is not a triangle. Okay? And then over here, 5 radical 3, and 10. Obviously, 5 plus 5 is 10. And then if you have this radical 3 next to this one, that's going to be bigger than 10. So that one will be a triangle. So those three are triangles. Now, what kind of triangle would they be? Okay, well, if it's not a right triangle, then the triangle is going to be acute or obtuse. Okay, so when is it going to be acute and when is it going to be obtuse? So look right here. When a squared plus b squared is greater than c squared, this is going to make an acute triangle. When a squared plus b squared is less than c squared, that's going to make an obtuse triangle. So let's check these three values to see what kind of triangle they would make. Remember, it's going to be acute, right, or obtuse. So I'm going to do 14 squared, and you always want to do the two smaller ones into A and B. And remember, these aren't always in order. So always be careful with that. And so is that, I want to put a question mark, to 50 squared. And so now it's just a matter of you using your calculator. So 14 squared is 196 plus 48 squared is 2304. So this is 2500 over here on the left. Is that equal to what's 50 squared? That is also 2500. Okay, so yes, they're equal. So therefore, when these two come out equal, and they're equal for the Pythagorean equation, that means this is a right triangle. Does everybody understand? 14 squared plus 48 squared is equal to 50 squared. Therefore, it is a right triangle. So let's try this next one, 50, 75, and 85. So we're going to check to see if 50 squared plus 75 squared is equal to 85 squared. So again, now we can just use our calculator. 50 squared is 2500 plus 75 squared. It's a big number. So this whole number on the left is 8,125. So is that equal to 85 squared? So let's see what 85 squared is. 85 squared is 7,225. So clearly they're not equal. So what is it? It is, this side is greater than this side. So a squared plus b squared was greater than c squared. And so we said that this is going to be an acute triangle. Okay, let's try one more, because remember this third one was not a triangle. So let's try one more. And this one has a radical, so don't be alarmed. You can still work that out. So I'm going to scroll down a little bit. So these are my two smaller sides. So I'm going to go 5 squared plus 5 radical 3 squared. Remember, you want to square that whole thing. Is that equal to 10 squared? So I'm going to put a question mark. Okay, well, now I'm going to actually do one step at a time. This is 25, And then what is 5 radical 3 squared? So if you have to, come down here and expand it. 5 radical 3 squared is like saying 5 radical 3 times 5 radical 3. Well, you learned how to multiply radicals just recently on our radicals assignments. So this ends up being 25 times 3, okay? Or square root of 9, which the square root of 9 is 3, and that is 75. So this is plus 75. And then 10 squared, you know, is 100. And 25 plus 75 is 100. So this is equal. So even though these numbers were kind of strange with the radical and all, this did satisfy the Pythagorean equation, and therefore these numbers are going to make a right triangle. And that is it, the Pythagorean theorem.